네, 안녕하세요. 한글로 발표하겠습니다. 예, 선박해양 플랜트 연구소
Nice to
오세웅이라고
meet you.
하고요.
I am Sewoong
제가
as
이제
introduced.
바다에
My work area deals with maritime ITS and mapping in that area. I would like to speak more on the GIS standard, marine GIS standard, and application cases. By profiling from ISO TC211 geospatial standards, we have over a 10 years time, we have devised a standard called Universal Hydrographic Data Model. It's called the S100. Before that, we had S57, a nautical e-navigation chart. And now S100 has been updated to edition 5.0 at the current stage. I earlier told you that we profiled from ISO TC211, and what I mean by that is that there are many different 19100 standards, including portrait, rules and applications, and schema. And out of that, we collected the data framework on S100 into one package. And that is the key of our project, the S100 framework for a standard. The application form is a product specification. Using the product specification, we generate maritime data and develop applications based on that. So in this ecosystem, the key aspect would be the registries. And later you will be able to see registries in different domains. Even in the field of marine and maritime operation, there are different domains, and more specifically, standardization also deals with terminology. The names and definitions must be shared across domains, and registries are there to help that. Starting from 2010, we have been piloting registries, which are made up of registers, and data, symbol, producer codes are what goes into the register and registries. These are some of the lists where you can view the registry. It is an international organization offering the list of registry that is in the hydrography area, and the feature data, the attribute data, the names and definitions are listed, and this serves as a backbone for our application schema, our product specifications, and everything that is provided in the S100. So going a little bit more into the registry, again, which is composed of registers. These are, again, defined and operated by international organizations, in this case IHO, and there are many different types of them. To name just a few of them, here is the IHO that is responsible for managing the registry and this standard, S100. And then there are other international organizations, IALA, International Association of Marine aids to navigation and lighthouse authorities, and then there's the World Meteorological Organization, and then the IMO, International Maritime Organization. IMO in particular deals with maritime organization, especially for disaster prevention and damage prevention. And other international organizations are ready to implement such standards in the purpose of data transaction and exchange. So, among these international organizations, to stimulate more data transaction and organic flow of information, standards play a big role. When we were profiling the ISO 19100 series, the schema language, image grid, the portrayal register, metadata, all of those that are related to maritime information, we took them and expanded to fit the need of the field. For example, if it's the same level or class of feature data, but it is not a spatial data, or if we grouped attributes, for example. So there were some tweaking that was needed to fit the characteristics of our field. And through this framework, the core purpose of what we were trying to do was to create a product specification. So each product specification is listed S-3 numbers, and each code for the GIS data product would be given to items. It could be bathymetric surface, it could be surface currents. So dealing with different types of items, different areas within the maritime operations, lighthouse also, aids to navigation information. So in different categories are a full list of items that are dealt with in the S-3 number product specification. So this is the full list you're looking at, and if you take a look at the categories in the S100, I earlier told you this has been compiled into a package. We often call it a one book, and this is a registry that is designed. So some chapters deal with that, designing registry and generating a registry. Another focus area is feature catalog. Earlier in the morning session, we also talked about digital twins, and it was mentioned that feature catalogs play a role in digital twins. If I can tell you what is different in our area, we use the DCG. And feature catalog actually means something different when it comes to maritime operations. XML data being standardized is what is feature catalog in this field specifically. So that will be made into an aerial and then developed and expanded into marine GIS data. So there are some different definitions for the same word. So as you have seen, there are many items listed in the SXXX product specification package, IMO, IOC, and different organizations and agencies will come into play, bringing more information on components. And if you look at the category here, there's the main document, including metadata, data formats, and so on. And then there's the feature catalog, that's XML based. And then there are symbols. Symbols play a big role in nautical charts. So there's the DCG that define the data format, and we also profiled OGC's GML. And then we have our own GML schema as well. So that also goes into the categories of the specification package. And the relationship between these At the top is the application schema, and from that comes the feature catalog, and the GML data, and so on. So when we're managing packages, there's the hierarchy of management. Now, on geospatial information standard, on real working level, everyday business, we catalog the validation data and the application data. When all that goes into play, the registry is the backbone. And each feeder catalog, to build the feature catalog, there are tools for building feature catalogs. There are the portrait catalog builders, and all those tools come into play as well. So you see the toolkit. I understand there's only limited time left for me, so moving on. There are some application cases using the standard for maritime ITS, and I would like to go over just a few of them. Per domain, we define the objects within the project specification. Now there's the bathymetric surface. One is the topography and also is the surface level. Then there's the GML level, which is vector data. And then there's the surface currents, that's the visual but also a GML data. There's water levels as well. So there are different types that can be categorized into similar data types. And the environment merged with those data is what we call navigation. So on profiling existing standards, we were able to devise a marine navigation system standard currently in place. And for maritime safety efforts, as you know, offshore you have limited access to communication, and the network situation can be different from in onshore environments. So using these navigation projects, we were able to help curtail some of the limitations that happen on maritime operations. And for small ships, we call it the navigation system, a maritime navigation system, including the router. It's about 3 million Korean won, and the public funding supports mounting these devices onto small ships in Korea. And we also have VTS. I'm sure many of you are already familiar with VTS, Vessel Traffic Service. Currently, it's on voice communication, but to transfer that into digital data and send the data as polygons, it would be much more useful. So that is one of the directions we're taking. Maritime autonomous surface ship is also one of the future directions we see coming into place. International organizations have acknowledged that this is a way to go needed for the future. So that's one of the R&D projects that are in place currently. Route is vital information in maritime operation, and there are businesses based on exchanging route information for safety and for economy. So those are some of the research areas as well. Marine weather, of course, is information that is very important. So grid products, vector-based products are being produced. And we are nearing my last slide now. So maritime digital twins are becoming a more popular word now in the field, and this comes from a different conference that I recently attended. So digital twins are becoming bigger in oceans as well. And profiling, ISO 19,000, 19,100 package series. The S100 standard category has become more advanced, so I believe there's more room for exchange as well. Thank you very much.